Welcome to this video lecture of hydration of cement. In last video lecture, we were discussing about box compound, which has formed due to the fusion in kiln. Now that box compound, tricalcium silicate and dicalcium silicate, these two compounds are most important compounds because they are responsible for strength. Together, they constitute 70 to 80% of the cement. Now, question is, why to understand about cement chemistry or the hydration of the cement? Actually, in this hydration of the cement, when anhydrous cement compound mixed with water, then it hydrate, it evolve the heat, and during that process, it react with each other and form a hydrated compound of very low solubility. And since after hydration only, the cement or the cement used in the concrete gains the strength. So if you want to understand that how does the concrete gains the strength, then you have to understand the chemistry behind that reaction. In an average, tricalcium silicate content in modern cement is about 45% and dicalcium silicate is 25%. So to understand this chemistry, this topic have to be understood. That is cement chemistry. Now, if we discuss about hydration of cement, then the water causes the hardening of concrete through a process called hydration. It is a chemical reaction in which the major compounds in the cement form chemical bond with water molecule and become hydrate or hydration products. Now, if we say that aggregates are chemically inert, then the cement is the body which combine them together. This hydration process can be visualized in two ways. First is through solution mechanism. In this mechanism, cement compound dissolve to produce supersaturated compounds, or you can say supersaturated solution. And that supersaturated solution forms which different hydrated products gets precipitated. And the second mechanism is when water attacks cement compound in the solid state, converting the compound into hydrated products. It started from the surface and proceeds to the interior with time. It is also possible that both mechanisms, that is through solution and solid state, this both mechanism may occur during the course of reaction between cement and water. The former mechanism may predominate in early stages since large quantity of water is available, and second mechanism may dominate in later stage of hydration. Now, since the reaction of cement with water is exothermic reaction, that is why when exothermic reaction happens, then it liberates lot of heat, or you can say it liberates considerable quantity of heat. This liberation of heat is known as heat of hydration. After 28 days of curing, cement grains have been found to have been hydrated up to a depth of 4 micron. Now, if we discuss about reaction, or I can say chemical reaction during hydration, then tricalcium aluminate react with gypsum in the presence of water, and it produce ettringite and heat. That is, tricalcium aluminate plus gypsum plus water is ettringite plus heat. Now this heat is, if you quantify it, it is 207 calorie per gram. Ettringite consists of long crystals that are only stable in a solution when gypsum is there or when they are reacting with gypsum. This ettringite does not contribute to the strength of cement glue. It only occupies the space. Now, this hydration of tricalcium aluminate or calcium aluminate system, it is CaO, Al2O3, H2O. This is formed. It means that when I am discussing about halide, when halide is hydrated, it produces calcium silicate hydrate, that is CSH, lime and heat. Now in this case, when halide is reacting, then approximately 120 calorie per gram of heat is liberated. This CSH has a short networked fiber structure, and it contributes greatly to the initial strength of the cement glue. Now once all the gypsum is used as per the reaction, now this ettringite become unstable and it react with any remaining tricalcium aluminate to form monosulfate aluminate hydrate crystals. These crystals are only stable in a sulfate deficient solution. In the presence of sulfate, these crystals resort back as ettringite, and when it resort back, then the ettringite crystal size is 2.5 times the size of monosulfate. So due to this difference in size, when sulfate attack is there, then cracks can develop. Now, when I am discussing about belite, that is dicalcium silicate, it also hydrates and it forms after hydration calcium silicate hydrate and heat. Now, in this case, heat is 62 calorie per gram. Now, you have to remember that this calcium silicate hydrate, it contributes to the strength of the cement. This reaction generates less heat and it proceeds at slower rate compared to others. It means that contribution of dicalcium silicate to the strength of cement paste will be slow in early stages. But This compound is responsible for long-term strength of Portland cement concrete. When I am discussing about ferrite, it undergoes progressive reaction with the gypsum. Since two reactions are happening, so in the first reaction, this ferrite plus gypsum plus water, it makes ettringite plus ferric aluminum hydroxide plus lime. Now, the ferrite further react with ettringite and it produces garnet. Garnet has not ever to do anything for contribution of the strength. It only takes space in the cement paste. So if you see that when it is hardened, then attaignite is 15 to 20% of the space the attaignite has taken. And thus calcium silicate hydrate, that is CSH, it has taken 50 to 60% of the space. And calcium hydroxide, that is lime, that is hydrated lime, it is taking 20 to 25% of the space. And 5 to 6% is voids. It is in the form of capillary voids. And air can be entrained or entrapped in it, which we had discussed in first video also, that 0 to 3% of the air is always present. Now, due to this reaction, pure tricalcium aluminate with water, the reaction is very fast and it may also lead to flash set. To prevent this flash set only, we had added gypsum in the cement in clinkering zone at the time of grinding. This hydrated aluminate do not contribute anything to the strength of the paste. On the other hand, their presence is harmful for the durability of concrete, especially where it can be attacked by sulfates, which I had discussed now. Since it hydrates very fast, so it contributes a little to the early strength. And we must know that 50% of total heat evolved occurs during first 3 days of hydration only. So if we understand about the role of water for this hydration, then we can understand the chemistry also and this hydration also. Now, tricalcium silicate requires 24% of water by weight of cement, and dicalcium silicate require 21% of water by weight of cement. So that is 24% tricalcium silicate and dicalcium silicate requires 21%. So we can take average of this. So on an average, 23% weight of water by weight of cement is required now. It is required for chemical reaction with Portland cement combination. When this water combines with cement, it combines chemically. Therefore, it is also known as bound water. Now, certain quantity of water is imbibed within the gel pores. This is gel water. It is different. Gel water is different than bound water. But gel water and bound water, they complement each other. So if quantity of water is inadequate to fill the gel pore, formation of gel itself will stop, and there is no question of gel pore being present also. It means the quantity of water which we have to mix should be considered very carefully. Now, we had discussed about 23% of average of water. It has been further estimated that about 15% by weight of cement is required to fill up gel pores. Therefore, the total quantity of water required is 23% plus 15%. That is 48%. Now, 48% water by weight of cement is required for complete chemical reaction. So, capillary cavities become larger with the increase in water cement ratio. So, theoretically, we can say that minimum of 38% water should always be present. That is 15% and 23%. But practically, we take 50% approximately. We will discuss it some other time. Now, increase in volume of gel due to complete hydration could fill up the space earlier occupied by water up to water cement ratio of 0.6 or so on. If water cement ratio is more than 0.7, then increase in, that is 70%, then increase in volume of hydrated product would never be sufficient to fill up the voids created by the water. It means that increasing the quantity of water does not mean that we can increase the strength also, and decreasing the quantity of water less than 38%, it also means that the gel pore will not be developed, and due to that the strength for which you had designed or we had designed the concrete or cement mortar, it cannot be reached. So by seeing this video lecture, you can give answer that why we were taking 38%, the minimum amount of water 38%. And second thing, you can give answer that what is the role of garnet in the cement or atrinite in the cement. And very importantly, you have to understand that during all the chemical reactions, heat is evolving, and to ensure that no crack should be developed due to this heat of hydration, proper curing is very much required. So this is very important topic to understand the chemistry behind the chemical reactions which is happening. Thank you.